Hello everyone, I'm Xiaogang. In this lesson, I will mainly demonstrate this effect. Actually, please note that we are using this real-time speech transcription. Let me emphasize again that we are using real-time speech transcription because you can see that the new version and the old version have different names here, which actually refer to different interfaces and calling methods. Okay, we are using this document, and we actually have code here, which is on my GitHub. What we mainly cover is this part of the code is right here. Actually, this code is the code right here. Yes, it's basically the same because this code is the same as part of the code in our latest plugin. Yes, part of the code is the same. So what we are covering is the code in here, and there are some comments here. You can take a look. I should have briefly introduced it to you before. I should have given you a simple overview. I won't go into redundant detail here. Okay, so then that is to say, we actually covered this before. But what was covered before was the first version. It was the first version because it was developed at the very beginning, a year ago. And actually, during our development process, you can see that this version has already been iterated to version 5. And in the meantime, regarding this audio, the audio capture part has actually been changed many times. So compared to what was in the video at the end, what was initially discussed versus after a year of iteration, after iterating 5 or 6 versions, our current architecture is relatively stable. And the reason we are covering this chapter now is because of this WebSocket real-time voice. Transcribing this is really classic. That is, talking about WebSocket. I think using this case study should yield the best results. So we are bringing it up again here and explaining it once more. And while explaining, I will tell you why it was designed this way, how it was designed before, and what the effect was during later iterations. Okay, so basically, these are the documents. If you are interested, please take a look. And the content we will cover might be a bit less than what is here, because this also covers some other procedural audio content. Okay, this mainly covers STT and TTS. And this course of ours probably won't cover TTS, because in version 5.4, the audio playback, the code for playing audio has changed. I haven't had time to update it yet. Okay, alright, so we can close these now. They're not needed because right now... Alright, now let's take a look at the effect. This is our blueprint. Click here to start voice recognition. Let me click it first. Hello everyone, I'm Xiaogang. Okay, this is the speech recognition area. It should have real-time streaming enabled. Yes, but the translation function is not enabled because this translation function is outdated. Yes, okay, we'll just turn it off. Okay, it actually only has 3 interfaces. You can see, so this thing is in the blueprint. It's just for display. And here, there are 3 interfaces. This one is start. This one is the most complex. We'll look at it last. This one is stop. If you must use it, then turn it off. And this is a force shutdown. Because when you turn it off, it still needs some time to release and process, right? And forced shutdown means that after this node ends, this thing is definitely turned off. It completely ignores everything. Anyway, I want to turn it all off right now. So that's what force shutdown mean. Okay, here we are. There's actually another node. You can see the current microphone's sound level should be STT. Should be this one. This one checks whether it is currently working. This one is also relatively simple. There's another one here. It gets the current sound volume. These are 2 purely parameter-based results. And then, let's take a look here. Through this difficulty node, it only has 2, 1 ID and 1 key. Because this one is relatively new, so it only needs 2 other parameters. Then we'll pick a random spot here. Place this character calculation, then here's the requested information. So the request information, actually, you don't even need to look at it. It mainly has this CN is enough. That is what your current language is and what you want to translate it into. Then these four options are all related to translation. Actually, we don't really care about this specific communication stuff because we are mainly talking about WebSocket, not this STT. There's nothing much to say about this. These are all some tier parameters. Then here are some ways to segment words and sentences. Just ignore it. As long as this route type is, it will return this character. Because you may or may not enable this character feature. Because after you enable the decision maker, it might be in a multiplayer scenario. If 2 people are having separate conversations, then it can recognize A and B. Tell you how many characters there are. Right? And this is the recognition mode. That is Chinese and English means. For example, abundant, you want to recognize it as abundant. Still in the form of A, B, and on. Just these anyway. Some parameters correspond to those in the documentation. Just match them accordingly. Then our first agent. You can see the first agent is the tentacle drawing because we now need the tentacle drawing communication result. After it connects, we will proceed with the next step of communication. So when our tentacle drawing succeeds, a prompt will be given here that we have successfully connected, and here are some redundant messages. We'll ignore them. Then after the tentacle drawing succeeds, we will then fill in. Only then will we turn on the microphone, capture audio, then continuously send binary data to the training flight. Then the training flight will continuously pass this data through, respond. It's respond again. Right, return this information to us. The reason why our size encapsulation is relatively complex is, first of all, it may involve streaming and the translation function like this. Then, according to our request, the response stages are different. We make a division. So if it is this streaming type, then you just print the streaming data in between. And then if it is just sentence by sentence, then just directly call this. And if it is this type with translation, then we just call this translation. You see, it's still relatively simple because maybe you request because the features you enable are different and the results it returns are different. So these data may vary. In fact, what we care about most is this recognized original text. And this is the translated text. Most of the time, there is no translated text. Then when finally closing, we have a delegate because when closing, it is a one-step closure. Actually, a normal closure is one step. There will be a prompt here. This is closed here. And this ID is our asynchronous ID. Right, you often use this ID. Okay, so in reality, this blueprint node is like this. Then we can take a look at the specific functional code. This should be the same as what's on GitHub and in the plugin. We are using the latest version to explain to you because this version is relatively stable after being updated. Okay, we have now divided it into many modules. We'll write it in a moment. There's no need to split it into many modules. Let's first look at this subsystem. This is our STT subsystem. It controls the audio production thread and the audio consumption thread. The audio production thread is provided by Unreal Engine, and the audio consumption thread needs to be defined by ourselves. There is no need to worry about the active part here. The reason for using the active part here is because we hope that this thing of ours, in other words, don't let users use it. All of our methods here are not meant for users to use because all our methods are written into the BPLibrary. You can see none of them are exposed to Blueprint, and these methods are all protected. Well, these three methods go without saying. This part determines whether it is working. Actually, how do we determine that? We have an enum. This enum will identify its different stages. So you could be ready. Hey, initialization in a selection complete means during communication. And then there is also a state of waiting to close. And another state is completed, right? This is a simple judgment. Then here we expose the interface. So this is the information we need. We have a requake info. We have 3 agents. Obviously, these 3 agents need to be activated here, right? Then we need these 2 to stop. As we're stopping, it is actually to close our socket. The reason why stopping here is more complicated is that we need to determine our current state and also release the corresponding audio production thread, the audio consumption thread, and finally send this close data. Then here we are. On our side, we also check whether it is currently working. Right, this method is ready. That is, whether it can be enabled. If it is already enabled, then you cannot enable it again, because if you enable it again, then spawning multiple instances of this audio consumption and audio generation in the game is very bad, and the flow is also incorrect. So we only allow one instance to exist at the same time. Then this part is the check. This part is the classic style that Xiaogang likes to use. That is this one-step execution style. Why do we need to do this one-step execution? Because you are communicating via WedgeCon. If you close or reopen WebSocket within WebSocket itself, then you are modifying objects in the container while iterating over it, which will cause a breakpoint. Therefore, here we let it all execute in one step. And obviously, this is for sending our binary data. Here it mainly handles big-endian and little-endian conversion. After the processing is done, we then let it call from the main thread to send via call, right? Remember in our first lesson, we sent that diagram. Okay, this part is for releasing the corresponding thread. You can see this place releases the corresponding line layer. This place releases the audio production line layer. This is the audio consumption line layer being released. And here we release our WebSocket. This place releases our current token information and proxy. And this sends the final end sequence. Of course, writing it this way is actually not very safe, but it's still okay, because the underlying layer should make a copy. However, writing it this way is actually dangerous. if you write it like this, writing it this way, how to put it? That is, this place, using this thing here is not very appropriate. You still need to follow our usage method. I mean, in the previous chapter, the camera capture, we showed everyone the camera, that is, the video stream captured by the Unreal Engine camera, and then used for detection. In that, we definitely demonstrated some transcoding, or even earlier. In the string, I said don't write it this way. Writing it this way won't cause problems. So I didn't change it, because since there's no problem, I didn't change it. But writing it this way is risky, isn't it? Just so everyone knows. The next... Actually, this part is for internal. What we actually use is the well-packaged WebSocket module. These main methods all need to be bound. These methods correspond respectively to connection success, connection failure, closing as well, receiving messages and sending messages. Then after this, connect succeeds. We just log a connection success, right? And after a connection error, we need to do a sample release of the corresponding resources. And one thing worth mentioning here, your UEC communication needs to contact your vendor, because different vendors have different communication methods. After our communication here is successful, there will be a situation like this. That is, after you connect successfully, how exactly was the authentication done before you connected? After you connect successfully, who sends the first message? Some vendors, after a successful connection, will send a message telling you the connection is successful. And you can communicate to their authentication. Must definitely be done before the connection. Another situation is, after you go up and successfully connect, your first message is your authentication information. After you send it, after the vendor verifies and approves it, then the vendor sends another message to you. Then you receive this message. Only then do you start transmitting your business information. So the detail here is that everyone should pay attention to how your backend interface is defined. And this close is when the widget is closed, whether we close it actively or passively. This will all be called. Then this on message means that upon receiving a message, it needs to be purchased. Here, because of this message, we can directly obtain the A string. It has already been converted for us. We use it here. Then, according to the different stages of this message, then this if like, after it successfully connects, it will send you a message indicating that authentication has passed. Then, after we pass authentication, here, this block of code is actually used to initialize our audio, start our audio thread, start up the consumer threads, respectively. After starting them up, we then perform a corresponding processing. If it fails, we will just log a message here. Then here we call the failure-related information, and at the same time, because they are coupled together here, this information is also the binary in the middle. After sending it, the response it returns is the text after parsing. So it exists in the form of this field. Therefore, in this part of the code, it is about receiving the response in the middle. The communication information in the middle. Okay, if it's like this, there might be some differences. It depends on whether you have translation enabled or not, or some other things. Then, it is also quite complex, and this is used for us to determine whether there is any problem with the information we sent. We can write one like this. This way, it works. This way, we cannot print it here, because all of this is binary information. It might not be printable, or it might be printable. If printed, it would be a very long string. So this method is commented out. So actually our real-time subsystem, it runs on our main thread. The main thread objects manage our audio consumption thread, manage our audio production, manage our network communication thread, manage these three threads. It also supports callbacks to the blueprint thread. So this is the most central, the most core object in the entire system. Next, let's take a look. Let's look at the audio production thread. This subsystem here is mainly responsible for producing audio. In fact, its approach is relatively simple. It does this here. Here, we go through UE. It has an edu. You can see there is a plugin called edu plugin. This is the plugin. Through that plugin, when we start capturing audio, we create such an edu capture object. Then through this object, we specify the corresponding parameters here, find the corresponding delegates. Then once we start capturing audio, it will take the audio captured by the microphone. After we have bound this delegate, because there is an add digital delegate here, once this delegate is bound, then we can obtain this audio data. After obtaining the audio data, we store it. After storing it, we have a container here. This container is actually here. You can see there is a lock here, because we also need to lock the audio consumption. So this is a static one. So it's this thing. We store it here, and it keeps storing data into it. When we close it, when we call it to close, we close this audio, and at the same time, we clear all our resources. That's fine. Okay, next, moving on. So this is the generation of audio. When you generate audio, you can calculate. What is it called? The size of its audio microphone. Of course, this size may not be accurate. You might need to multiply it by some coefficient or something. We can see in our sphere. Here is an edugality one. We posted this thing here. This place is a dog capture. This place has a set value size. Here, so this is the audio size. How is this size made? Actually, it processes our audio point. This processing is related to mathematics. It's just a calculation, something like the average volume size. After processing with this mathematical method, when you access it, you can get the size of this audio. You should basically see a get value size. That's the method. So this audio size tells you what is the size of this audio at this moment. Okay, then let's go back to our thread. This thread is the most classic way to write a thread. This is an audio consumption thread. Its function is actually quite simple. It simply retrieves data at a certain time interval. When our audio object can be retrieved, then it means we have successfully retrieved it, according to our corresponding audio parameter channel parameters. As long as the retrieval is successful, we then call the main thread. This goes back to our subsystem. Here, we just need to send this data over. Okay, so this is the consumption ready-made of this audio. Okay, so overall speaking, we have basically finished explaining everything to you. Okay, there are also some rescore ones, which are record info and respond info. These are all relatively simple. They're mostly similar to what we wrote before. There is no need for us to go over this part again and emphasize what these fields mean, because you can just check the documentation. These are all quite simple, because by now, we have actually written tens of thousands of lines of code. These are all relatively basic things. A development method in knowledge basically also defines a log. Well, this thing is a speech transcription. Let's do it this way. This part is controlled here, because we still use subsystem. To implement this speech transcription, it differs from the real-time speech transcription. The difference is that speech transcription has its communication protocol is the same, but the structure of its communication protocol is different. And the way it sends this audio is also different, because it needs to wrap a save. This is speech transcription. This is real-time speech transcription. So that's roughly the difference. And this speech transcription is a feature within the paid plugin, so you probably won't be able to see this code. Okay, we have just briefly gone through for everyone in this session. We are going to write some code in this chapter. But of course, regarding the specific details, we haven't explained them yet. That is specifically the audio format, why it is like this, why the interval is so long, and how it is calculated this way. Then when we add a lock, why add a lock? When do we not add a lock? Then we will put this in the code and show it to everyone. Because we are going from top to bottom, we have already finished explaining the top part. Now we need to start writing this code step by step from the bottom. Okay. We will stop here for this lesson. Thank you, everyone.